Hi guys, welcome back to the channel. Hope you all are doing good. So let us continue with dynamic programming, and in this video we will be solving a question which is seeming to be like permutation combination. Actually, to become strong at dynamic programming, one of my seniors had suggested me, and even some of my friends also told me that your permutation combination understanding should be good. So if you had done that correct in your 10th, 11th, 12th standard, then you will understand DP problems much better, and you can code it by yourself actually most of the time, because many permutation combination problems are like DP problems only because they have the sub problem, the optimal substructure, and the repeating nature. It is there in permutation combination. So forget all that now. Anyway, let us see this problem. Given a fence which has n posts and k colors, find out the number of ways of painting the fence such that at most two adjacent colors have the same, at most two adjacent posts have the same color. So let us write the data. So what are we given? We are given n posts and k colors. Okay, so you can think of the fence like this. So this will be the fence. Okay, I'm trying to draw, not so neat, but try to visualize what is it. So these are called posts and there are n of them. Fine, this is going to cover the fence. Now we have k colors and we have to paint the post such that no two adjacent, maximum two adjacent posts can have the same color. That means let me represent the posts as dash. Okay, so suppose like this it is there. Then let us say I have the colors red, green, blue. Let me say I have three colors. Okay, red, green, blue. Then what the question is saying, you can't paint like this. Three consecutive red is not allowed. But if you erase this, two consecutive same colors are allowed. So this is fine, but R again, red, 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 three consecutive not allowed. So at max, at most two adjacent posts can have the same color. So this is the restriction. Okay. Now forget that this is a dynamic programming problem. Keep in mind that it is something like choosing. You have to choose colors. Just keep that. And we will see how we can get the DP solution. Okay, so forget all that now. Let us just start with whatever we know. So what do we know? For example, if n is equal to 0, if there is no post only, how many ever colors you have, you can't color it. So number of ways of coloring will be 0. Correct? So this is understandable. What about n equal to 1? Suppose there is only one post. So there is one post like this and you have k colors. Suppose k is equal to 3, just for example, RGB, three colors, red, green, blue. Okay, then how can you color it? You can either color it with red or with green or with blue. How many number of ways are there? 3. K, in general, k. So if n equal to 1, what is the answer? K. Answer is over here. What? Total number of ways we can paint. That is the answer, right? So we got to know two things. What are the two things? Let us write them down. If n is equal to 0, answer is 0. If n equal to 1, answer is k. Now what about n equal to 2? Let us see for n equal to 2. I think I should erase this. Yeah. So suppose n is equal to 2 and let us say k is equal to 3. I have three colors RGB. Okay. Now how to paint the two posts? So consider these dash lines as post. So I can do RR, I can do RG, I can do RB. RR is allowed because I can paint at most 2 consecutive posts with the same color. So what did I want to show you? If I fix one color, then I have how many options? K options. If I fix one color, I have K options. So for K colors, how many options I have? See, if I fix one color, how many ways I have? K ways. For K colors, K into K. So this is one way of understanding it. Let us try to see the same thing in another way. So what is the another way going to be? So there are two things in this problem, right? Either you can color the adjacent post with the same color, or you can color it with a different color. So there are two things in this problem. So let us say you color the first post with R, red. Now let us say we color it with the same color, so R. Like this, how many options you have? You can do RR, BB, GG. That means the second post you color it with the same color that you used to color the first post. So like this, how many options are there? K options. K is 3 here, 3 options, K. So what does it mean? If you want to color the second post with the same color that you did for the previous post, then you have K options. Now let us check for different option, like different color. Suppose R you have colored, you don't want to color it with the same color in this post. How many options you have? So out of RGB, you don't want R. So how many options? 2 options, either RG or RB. Correct. Now same thing let us do for the remaining colors. So I fixed R first. So let us say I color B. First post I color with B. Now how many options? Again RG. I can't color with B because I've decided that I will do it with different. Okay. So same thing with G. How many options are there? 2 options, RB. So what did we understand from this? For this thing, how do we write this mathematically in terms of K? That is important. So for one color, in this case, if you want to color it with different color for the adjacent post, if you want different color, for one color we will have K minus 1 ways. See, if I colored with red, I have 2 options. 2 is equal to 3 minus 1. 3 is K over here. So for one color, if I fix, I have K minus 1 ways of painting the other post, the adjacent post. Now for K colors, how many will I have? Simple, K into K minus 1 ways. See, you can verify it. So how many ways we have here? Totally 6 ways, right? So put 3 here. 3 into 3 minus 1, it is 6 only. But what is the total number of ways? Now we will see total number of ways. So what are these? This is for different color. We paint the second post. Second post we paint what? Different color. Different color painting. Okay. Plus, what were the other things? We paint it with the same color. RR, BB, GG. So this is same color. So how many ways were here? 6. How many ways were here? 3. So total 9. But how to write this 6 and 3 in terms of K? Here we can write 6 and 3, but in the problem it is K, right? So what did we get for this expression? How did we get K? That we have to see. We got 6 as K into K minus 1. And we got 3 as K. So total number of ways will be addition of these two things. So total number of ways is K plus K into K minus 1. If you simplify this, what will happen? It will give us K square only. So you can verify, see 6 plus 3, 9, which is 3 square. K is 3, right? So what did we observe from here? Let us erase all this. So what did we observe? Let us summarize till now whatever we have learned. See, If n is equal to 0, there is no post. So 0 ways of coloring. If n is equal to 1, whichever color we can use, anything. So k ways. N equal to 2, what is the total answer? K plus k into k minus 1, which is actually k square if you simplify. So what am I trying to do? See, something like Fibonacci series, like the value for n equal to 3, it should depend on the previous two values. So some kind of intuitive thought you should get that for n equal to 3, it should depend on the previous two values. But let us see, let us verify, let us not just talk in the air, let us see how it is. Now suppose n is equal to 3, k is equal to 3 only, 3 colors R, G, B. Now again, let us take the two cases. What are the two cases? Now see, this is the first post, this is the second post, this is the third post. Now we are assuming the first two posts are already painted and we are going to paint the third post. So we should compare third with second. That means what? We should see if we are coloring third with the same color or with different color. So let us see that. Let us see how many options we have. So always we will have two things only. Let us keep those two things. Either same color we take or different color we take. But let us see how many total number of ways we can paint for 3 posts. So suppose I fix the first 2 posts as painted with red color, RR. Now tell me one thing, can I put R here? See, according to the question, go back to the question, at most 2 adjacent posts can have the same color. That means what? 3 can't have. So you can't paint with R again if the first 2 are painted with R. Third one should be either G or it should either be B. So 2 options. Let us write 2 as k minus 1. Okay, in general k minus 1 options. Same thing let us do with BB. Suppose first 2 posts are painted with B. Then can I paint it with B, third one? No. K minus 1 options. Similarly, let us say first 2 posts are painted with G. I can't paint with G, R and B, 2 options. So if I fix one color, like if I say I'm going to fix one color and I'm going to paint the first 2 posts with one color, I have how many options? K minus 1. Like that I have K colors. I fixed R first, then I fixed B, then I'm going to fix G, 3 colors. In general, K colors. So for K colors, I have how much? K into K minus 1. So it means what? If the first 2 posts are painted with the same color, how many options I have? K into K minus 1 ways of painting the third post. And this is only if the first 2 posts are painted with same color. So this was one part. This is only one part. Okay. So let us write this K into K minus 1. So what it was? So suppose same color, let me write here K into K minus 1. Now let us check for if the first 2 posts are painted for different colors. What I'm essentially trying to do is I want to derive the expression and I want to show how we can use DP in this problem. So suppose see, I do R and B, R and G. For example, R and G. If I paint like this, first with R, red, next with green. Now tell me, can I paint R here? Can I paint red? Yes, of course, because see, it is not violating this, right? It is not violating that at most 2 adjacent should be. So it is not violating, we can. So if I fix R and G, how many options I have? I'm fixing R and G. Can I paint G here? Yeah, because see, 2 can be printed, right? At most 2 adjacent. So this is also valid. B is also valid. So similarly, if I now do R with B, if I do R with B, I fix this, I fix these two that I have painted in this manner. Now how many options I have? Again, I have 3 options. If you observe carefully, I can paint B and B adjacent, I can. That is allowed. So now tell me, if I So how many like this can I make combinations? So how many combinations essentially can I make? See, we should first consider in this much part only. What did we observe over here? If I paint the first two posts with different colors, for each such combination, I will have k ways. See, I have 3 ways here, 3 ways here. So k ways I will have definitely over here. But how many ways are there to make these kind of combinations? What is these kind of combinations actually? What is this if I consider only first two posts? It means that I am coloring the second post with a different color from the first post, which we have already derived, which is k into k minus 1. You can rewind the video and check. See, what are we essentially doing now? We are finding out how many ways are there to paint first two posts into number of ways of painting the third post. So RG, RB we did. Now we can do for BR, BG, and also we can do for GR, GB. So for GR again k ways, for GG again k ways. Because I can put RGB again for third post, right? This also k, this also k. So what did I try to tell? We will definitely have k ways of painting if we have considered that the first two posts are painted with the different color. Or in a better way, if I have to tell, we will have k ways of painting the ith post if I minus 1th and I minus 2nd posts are painted with different colors. So essentially we have to multiply k with how many ways are there to get this answer. That is, how many ways are there to paint the previous two posts in different way. That is k into k minus 1. Already discussed in the example where I was explaining for two posts. So I should do this k into k minus 1 into k. This will be total number of ways to paint the third post, given that first two posts or the previous two posts are painted with different color. So this is one part. What was the other part? Other part was k into k minus 1, if you remember. If you remember, see, I wrote here, right? Same color, k into k minus 1 plus k into k minus 1 into k. Now let us write this mathematical expression in a different way to make you understand. So see, for n equal to 3, we are getting total number of ways as k into k minus 1, which is this. And what was this? K into k minus 1 into k. So k into k minus 1 plus k into k minus 1 into k. Let us rewrite this expression to see how we can use dp in this problem. Let us rewrite. Let us take k minus 1 as common. So what will we get here? We will get k plus, see, I'm taking only k minus 1 as common, k plus k square I will get. If you observe, for n equal to 3 we are getting this. But what is this and what is this? This is the answer for n equal to 1. This is the answer for n equal to 2, which means dp of I is essentially k minus 1 into dp of I minus 2 plus dp of I minus 1. So essentially it is this. That is why it is a dynamic programming problem. If we know how to do this, we can optimize our answer. You can verify for n equal to 4. Let k be 3. N equal to 4, you try to verify and see if it is correct. So this is what I wanted to actually tell you, that forget it is a dynamic programming in the initial part. Try to do it with permutation combination. In the end, you will realize how it is dynamic programming if you just separate the terms and write it in a particular way. So if you know how to do this, then you are actually a genius. Well, even I had to struggle for this, but I hope I'm able to explain to you now. I hope you're able to understand. So in the future, if there is a similar problem where instead of 2 adjacent, if there was suppose 3 adjacent, then you try to make your own dp function. Try to make this dp function by yourself. by changing this at most 2 to at most 3. Let us see what answer you will get. I hope this explanation is clear. Let us go to the coding part. It is a long video, sorry, but I had to explain completely. So let us go to the coding part now. So what all do we need? First of all, let us see that. We will need a DP array. What is the size? N plus 1. There are n posts because 0 indexing will take n plus 1. And in this problem, it also says that we have to return the answer modulo 10 power 9 plus 7. So let us store that value in a variable called mod 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, so this much we know. Now what all we did, n equal to 0, what was the answer? So dp of 0, what is the answer? 0. What is dp of 1? If there is one post, we have k ways. What is dp of 2? We already saw that, right? K square. Now let us start for, let me take long int only. So now let us start from post 3. For I equal to 3, I less than or equal to n plus I. Now simple. You don't have to worry much about mod because if you observe k value here, it is 100. Maximum value of k is 100. So you can just say dp of I is equal to, just say what, k minus 1. We derived the function, right? K minus 1 into dp of I minus 2 plus dp of I minus 1. And let us just take mod over here. Finally, we'll return dp of n. So let us submit and see what is the answer. And it is correct. And this is how we solve the problem. Okay. I hope you could understand. And I hope in the future for these kind of problems, you can make your own recursive function. So basically, you need to know permutation combination and basics of that only. And you should take some test case examples and try to get this dp function. What is it going to be? That you should understand. And in terms of k only, you should write the mathematical equation in such a way that you will get the dp function. So that was one interesting thing in this problem. And such kind of problems are usually tough because you need to spend time. You have to have patience. I hope I could explain to the best that I can, and I hope you understood. Please share this video with all your friends. It might help them. Subscribe to the channel. It will motivate me. You have been supporting me so long. Thanks for that. And that's all for this video. Take care. Stay safe. Keep learning. Keep growing. Stay tuned. Bye.